Thank you for being here. Thank you for joining us live if you're live. This talk is called RxJava, Ratpack, and Couchbase. My name is Laurent Doguin. I am a Couchbase developer advocate, which basically means I go to conferences and I give talk about various topics like RxJava or Ratpack or mostly Couchbase. You can follow me on Twitter. You can send me an email. I'll answer to every one of you as much as best as I can. I'm pretty easy to find. Just type my name on Twitter and everything should be fine. And with that, let's get into the talk. I have 45 minutes. There's going to be sometimes about Ratpack. There's going to be a bunch of time about RxJava and why it's interesting, and then Couchbase, Ratpack, and RxJava, how it works, what can you do with it. And then I'll show you some code because it is a developer presentation. So Ratpack, if you type Ratpack on Google, that's what you get. Ratpack, their Ratpack, was banned in the 60s and 70s by Frank Sinatra and some other cool famous actors and singers at the time. So if you're looking for Ratpack, the web framework, you need to type Ratpack web and you'll find something like this, which is a native-based full-stack non-blocking web framework, which might be weird if you're not familiar with all these terms, and we're going to explain some of them during the talk. So in a nutshell, it's asynchronous. Asynchronous, if you do, and you probably do, some JavaScript, or if you did some JavaScript at some point in your life, you might have done some callback, which is basically a way to do asynchronous coding. You write a function that takes another function as parameter, and that function will be executed once the first function, the one that you call, has finished. So basically, you're declaring something that will be executed asynchronously. To show it different, to explain this differently, you have the call of that method that takes a function in parameters, and then you have another function. If everything was synchronous, you call that method, you wait until the first method has finished, then you execute the method that you gave as a parameter. That's the synchronous way. If it's asynchronous, you execute that method, you go on to the next line and continue, and once the first method will have finished, then the other function will be called, and that's basically what async versus sync can be, how it can be understood, but like quickly. Blocking and unblocking, I have a slide about this in, well, that's the next slide. It's built on top of Netty. Netty is the most modern network stack you have in Java right now. It's great to do non-blocking and async stuff. It's actually based, Netty is the basis for Vertex and Ratpack and many other Java frameworks that are async and non-blocking. It's a lot like Node.js in a sense. Node.js uses an event loop, Vertex uses an event loop, but then Node.js has just one thread, and Vertex uses the JVM, not a stupid JavaScript VM. I hate JavaScript. So it's better to have this multi-threaded on the JVM. It's unopinionated in the sense that you have the choice to choose the modules and framework you want to work with, but it's actually, that's what they say, but it's actually quite opinionated in the sense that you have to write asynchronous non-blocking code, which is a strong opinion when you are not used to it. So that's one of the interesting facts. It's based on promises. If you did some JavaScript, you might know that promise is a way to write asynchronous code, similar to a future or completable future in Java. Fully based on Java 8, if you use Java 6 or Java 7 or even the others, that won't work. You have to use Java 8 for various reasons, mostly because Java 8 brings up lambdas, and lambda are great when you do asynchronous programming, because when you do async, usually you give a function as a parameter, and if you give a function as a parameter in Java, well, before having lambdas, you couldn't give function. You had to declare a new class implementation that just has one function, which is super hard to read and just ugly, and that's why Java 8 is so cool. And it comes from Ratpack. It comes from the Groovy community. I don't know if you guys know Groovy. Groovy was one of the first JVM languages that came out. I think it was the beginning of Java 7. And there was already lambdas, and you can do several stuff. I mean, Groovy is great. And as such, they have great Gradle integration because Gradle comes from the Groovy world. And it's great for IO-bound application. I will explain exactly what that means, but basically you should use RxJava or Ratpack or basically async stuff when your application is IO bound, and we'll explain what IO bound mean in a minute. So this is maybe the most interesting slide of this talk, first slide, but that's fine. Please stay. It's the difference between synchronous and asynchronous IO, input and output. The traditional model, which is this one, the first one, uses could be seen as a servlet if you are used with to use web application servers. A servlet, when it's configured, basically you say I have 200 threads, which means I can handle 200 requests at the same time. If there's 201 requests at the same time, there's one request that's going to wait because there's no thread to, do something to answer to that request. And how it works is there's a request coming in, a thread takes the request, and then usually when you have a web request, you're going to do some work, some kind of work. Maybe some CPU computation. Maybe you're going to call a database, which is network call, which is I/O. Maybe you're going to read or write on disk, which is I/O as well. And basically, you're going to wait until you've done that I/O works. So until you've called that database and went through the network latency and waited for an answer to come back from the database, and that's when it has answered, then you can serve the request answer to the client. So basically, you have to wait until this is finished to take another request. Basically, what you're doing is blocking. You're just waiting for something to happen, which is sad because while you're waiting, then you could be doing something else. You could use your CPU, you could do something else than just waiting for a network call to be finished. And then there's the asynchronous way of doing things, which has been popularized by Node.js, that uses what we call an event loop instead of using multiple threads. So an event loop, there's basically one thread, a loop, request comes in the event loop. And the requests, you define declaratively what you're going to do based on that request. You spawn that in the thread somewhere else, and then you take another request. And you keep on taking requests. You're never blocking. The goal of never blocking is to avoid being in this situation where your thread is just waiting for something to happen and you're not using resources as efficiently as you could. So because of this event loop, you take every request that comes in, decide what you're going to do with it, put that in a queue or in a stack, and then once it's done, put it back in the event loop and send it back to the client. And this way, you don't have to wait for I/O. So if your application is I/O bounded, which basically means it spends too much time or majority of time doing I/O application, like calling a database, like Couchbase, or reading or writing on disk, then you're probably better off using an asynchronous non-blocking framework like Ratpack. And so how does Ratpack work? It's pretty simple, really. There's a static method called start from the Ratpack server object. It takes a server as a parameter, and a server allows you to declare several things. And one of these things you can declare is a chain of handlers. What is a handler? A handler defines a URL. So if a request comes on my server/file, I can associate an handler for /file, and everything that will go through /file will be managed by the handler that has been declared /file. And what that handler will do is have a context object, and the context object gives you the request, the form, the response, gives you everything you need, basically, to send back a response to the client. And here what I'm doing is just rendering a string hello world. So that's the basic hello world in Ratpack. You don't need to package this in a while and deploy it to an application server. It's just, that's the main method. You just package a fast jar and just run it, and that's it. You don't need to do anything else, which is why it's so cool, which is why Vertex is being quite popular as well. It's you don't need to deploy it to package a WAR and to use a big fat application server. That are still cool, but yeah, microservices and everything, you have to use lightweight stuff. So there's a plugin in module systems. It's based on Juice. Juice is Google technology, and it's used for dependency injection. And that's what Ratpack uses for all the different modules that they offer. You don't have to use Juice. It will be used low level by Ratpack, but you won't see it. And you could use another dependency injection framework like Spring, because maybe you already have some Spring code somewhere, so it's fine. In that sense, it is unopinionated because it gives you the choice to use the framework, the DI framework you want. And it's not much, it's much more of a module than a plugin, much more of a decoration than a plugin, in the sense that when you write a plugin, usually someone has defined a service and some way to extend that service. And what a plugin is basically is an implementation of some of those extension points of the service. So you have to know exactly what to extend to write a plugin. A module is a little different. We just add additional behavior, additional stuff, without having to know what already exists. So it's much more flexible. In that sense, there's many modules. There's a Pack4G module for authentication. There's every module for templating system, handlebars, timeleaf. I don't know if there's a JSP module, maybe. I don't know why you would use JSP, but why not? There's a module for everything, basically. There's not one module for Couchbase yet. Maybe we'll write some. We'll see. And so why would you use Ratpack? Well, we touched that a little bit. Because you spend too much time on I.O. is a good answer. And of course, if you use a database, then there's a significant amount of time that will be spent in I.O. because basically it's a network call to a database. If you're heavily running on disk, the same thing. It's, again, I.O. And this is pretty much the behavior of any modern web application, right? There's rarely some web application when you will compute some stuff, do some analytics, that kind of stuff. Usually you use existing stack of framework that are specialized to that, like Spark or Hadoop or whatever other analytics tool. So, for the web, which is what most digital economy people uses or do, then it makes sense to use, it is I/O bound, so it makes sense to use something like Ratpack or Vertex or all these asynchronous non-blocking frameworks. That doesn't mean everybody has to do it. It will be more efficient. And why it, I said Ratpack, Vertex, why particularly Ratpack? Ratpack has a nice way of declaring non-blocking deterministic function or code. And it's really made for the web. It has some amazing web modules. I don't know if you've tried Vertex. Vertex has a web module, but it took me way more time to do what I'm doing with Ratpack with Vertex. Ratpack is really focused on user experience and the web part. You can do much more stuff with Vertex, but if you want to do web, I found Ratpack to be a better suited solution. Vertex might be more efficient in terms of resources and everything, but the most easiest one to use, especially if you want to incrementally go into the async non-blocking space, is Ratpack. If you use Vertex, you basically have to migrate everything to Vertex. Ratpack, you can take things more slowly. Like, I'll always show you an example. And the way we do async and non-blocking with Couchbase is by using this library called RxJava. By default, the SDK will expose a synchronous blocking interface, but everything that's being done under the hood will use RxJava, so will be asynchronous and non-blocking, but by default you won't see that. And then you can ask for the asynchronous interface and start using RxJava naturally in your code. So why would you use RxJava? Because blocking is bad, we saw that before, and especially because RxJava will allow you to write async code in a better way than using the traditional way of doing it, which are callbacks or future. Callback doesn't allow you to do composition, which is basically chaining calls, or if you do that, you have a big, bad, fat callback hell, and I'm going to show you what it is in a minute. And then there's future, which was the async API introduced in Java 7. There's a get method that nobody understood. When you have an object, you call get. That's what people do, and get is blocking, so it's kind of against the purpose of doing something asynchronous. And it was really hard to compose, so actually in Java 8 they spawned up, they added a completable feature, which is much, much better than this, but still. This is what you have on Google if you type callback hell. It's a good definition of how you try to call the asynchronous way using callbacks. So, this thing, execute this thing, blah, 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 and it's just super hard to read, and it's just bad. RxJava comes up from a company called Netflix, which I'm assuming everybody has at least heard of a little bit. Netflix have lots of cool open source projects, and they were looking at what Microsoft was doing at the time. And actually, RxJava comes from the Microsoft world, which I think is quite interesting and telling. And basically allow you to go from the iterator retrievable model, which is pull, give me the next version, to a push model based on observable and observers. And it's a way to do asynchronous, compose, etc. I will give you some example. Now, RxJava is usually associated with the word reactive because it's sort of a reactive stream implementation. Reactive stream, I think there's a website called reactivestream.org. I invite you to check it out. It basically gives you some basic rules about how to do reactive stuff. And what reactive means basically, outside of IT, outside of the computer world, let's pretend you have a pool and you throw something in the water and the water is doing some things, that's being reactive. If you throw many things at the pool, it will overflow. Basically, it's reacting to what's happening. That's all reactive is about. It's just about, it's pretty much, the name says it all, but it's the same for IT. That's how it works. It reacts to user load. If you have many people going to your website, if your website is reactive, then it will do something based on that overflow of load, or based on a failure, or based on events, stuff that could happen. And in the modern world of distributed application, distributed database, the more distributed you are, the more you increase your chance of having issues. And if you have issues, you want to react to those issues. So that's why reactive is important and interesting when you do distributed application. Yeah, that's one of the reasons why latency as well. If you're basically waiting for all the thread of all the requests to be available, then it's just freaking slow and you're unhappy and the world is bad and you choose another application. So that's just why would you use RxJava, why would you use Ratpack. Now let's do a small RxJava 101. Go on github.com/reactivex. There's several implementation of Rx. There's one in Java, there's one in JavaScript, there's one in Groovy, there's one in Ceylon, there's one in pretty much any languages. And it's quite nice when you do microservices, especially when you do polyglot microservices, because you have different languages. And if you use Rx on all these languages, basically you have a common API that you can use. I mean, it's not exactly the same, but the operators are the same, the words are the same. It just feels better and easier to do polyglot with the same libraries. So basically, the synchronous way of doing things, I have T or I have an interval of T. The asynchronous word would be future or completable future and observable. What you can see right now, maybe one of the flow of RxJava is actually, you can see it here. If you have a method signature, I've written something, you know exactly what you get here, you know exactly what you get there, you know exactly what you have here. An observable of T could have just one element. So actually, it could also be here. So semantically, you don't know if you're going to return one object or many objects. This has been fixed in the latest RxJava releases. It's been fixed into a reactive stream. It's been fixed in Reactor, which is another reactive framework as well, made by the Spring folks. But that's one of the downside at the time of when I prepared that talk. Again, another example of going from pull to push. Pull, give me the next object. If something's happened, you throw an exception, and when something is finished, you return something. If you're asynchronous, you have an observable, and basically everything starts with on because it's all event-based. There's a new stuff coming up in my observable, which is a feed stream. Something's happened, let's do something. A new object happened, let's execute on next. A new error happened, execute on error. There's no object anymore, and the observable knows that it's finished. Let's execute on completed. How does it work in terms of code? Well, if you're familiar with Couchbase, we store documents in what is called a bucket. So a bucket object gives you a link to that database of objects, of key value objects. And I said by default that bucket was synchronous. Here I want the asynchronous interface, so I'm calling the async method. And then I'm doing a simple get, giving the ID of a document, the key of a key value pair. And what it's going to return to me is an observable. Now what's interesting to note here is that if you only write bucket async.get, nothing happens. It's not fetching any documents. You're just describing something that will be executed sometimes. It will actually be executed once you call the subscribe method. So you can write asynchronous composable code just like this, just by chaining functions, and it won't be executed. That's extremely important when you do distributed systems or async system. So the get will actually occur once you've subscribed to that method, and subscribed implements three methods. The one I showed you earlier. What do you do when the stream is completed? What do you do when there's an error? What do you do when there is a new element? This is a marble diagram. If you know RxJava already, maybe you saw them. This is how the RxJava documentation works. Basically, they give you marble diagrams to explain how RxJava transformers, RxJava functions work. And this function just takes an array of stuff and returns an observable of stuff. In terms of code, this is how it looks like. It's a static method. I give it three strings, and so the two first line gives you an observable of strings, and if you subscribe, then you start doing things, and that's another way of subscribing. You can define an action for every thing that's happening, so it's just going to print got A, B, and C. There's many other ways to do observables. One is called interval, and basically this will each second do 0, then 1, then 2, then 3, and 4, etc. So you can do some throttling, stuff like this. So each 2 seconds, I'm going to write 0, 1, and then 2, and then 3, and then 4. So 0, 2 seconds, 1, 2 seconds, 2 seconds, 3, etc. You can also create your own observable. That's just for reference here. Most of the people that use these methods are basically implementing their own operators, so we don't have to talk too much about this, but this is probably the most important operator or function you have with observables. I have an observable of stuff, of circles. So document dot maybe a query, because a query is not going to return one document, it's going to return many documents. So let's pretend a circle is a document. And I'm not really interested by just the document object. What I'm interested in is the content of the document, because the document in Couchbase, it's a key value, you have metadata, and then you have the JSON string. And all I want here is the JSON string. So if I call map, and map is a function that takes the document as argument and returns the content, the JSON string. And that's exactly what it is, and that's exactly what it does, and that's exactly what you see here. Give me a document. I don't care about the document, actually I'm more interested in the content. So that's the map here. Again, if you don't call subscribe, nothing happens. And then there's the flat map function, which is slightly different. And you'll see the difference if we show the method signature. But basically, this is taking an object and returning an object. That's what the map function does. The flat map function is taking an object and returning an observable of objects. Okay? But then in the end, you only have an observable of object, because what it does is merge every observable that come out of this function. I hope it's not filmed, because anyway. It's fully asynchronous, and you can see this because if you have two successful objects coming in the stream, you can see that they not necessarily come up synchronously. So it is fully asynchronous again. So flat map allows you to take an observable of stuff and return an observable of other stuff. Which works best for queries? There's several ways you can query documents in Couchbase. One of them is views, which is exactly what I'm doing here. I'll tell you more about those different ways later. I'm doing a query, give me the 100 first beer of the beer sample, because we have some data sample available in Couchbase, and one of them is the beer sample. And I have this huge object of stuff that comes in, and I don't really care about all the metadata. I said just give me the rows. So I'm going from an observable of async view result to an observable of rows, which are async view row. So I have an observable of async view row. A row has a document and more metadata. Again, I don't care about those metadata. All I want is the document. So I'm calling get document, basically. And then I have three new functions that you haven't seen right now. Filter. Filter allows you to filter the content of the observable. So for all the objects that comes in the filter function, if this returns true, then you pass the object. If it returns false, then you just dump the object and you forget it ever existed. And this way you can count out of the first 100 beer, which beer have an average alcohol by volume superior to 5. And something that's even more interesting is this. You're defining a global timeout for the whole operation. Basically, you're saying if this takes more than 10 seconds, if it takes more than 10 seconds, throw an error. And again, if you don't call subscribe, nothing happens. Now, try to think of this the synchronous way, and try to think how you would apply a global timeout to all of this. And it should be more cumbersome, and it should look weird, and you shouldn't feel happy about it, and this is much easier to do. I hope. And if it's not, then I don't know what to do. But it should work. There's more operators. This operator is called group by. So what it does is group the observables into several sub-observables, or it's probably a map, actually. So what you can do is give me all the document from the beer sample. This is actually what is called the NCL query. NCL is our query language. It's SQL for JSON. Select from blah, blah, blah. You can see that it's not a string. It's using a DSL that we wrote, so it's easier to actually write this in Java than just writing the string. It doesn't really make sense for something as simple, but I assure you that when you write very complicated query, it's quite nice to use this DSL. I'm doing my query, and then I'm grouping the results. Each document from the beer sample have a field called type, and types equal beer or types equal brewery. So what you end up having here, once you subscribe, is a map of key beer and content, the other stuff. You can do buffer. So what you're doing here is every 100 milliseconds, I'm emitting something, but I'm going to buffer it into 5 seconds. 5-second buffer, and then I'm going to do an operation on Couchbase. And this is how it looks like. So 100 milliseconds, 10 per second, 5 seconds, so 50 operation per buffer. And what you see here is 50 operation every 5 seconds. The filter observable, the filter function, you showed it before. I was filtering by alcohol by volume. I put it here again to show you what would happen if it was only Java 7, which basically gives you the anonymous class that you will have to implement just to return a single function. So it's more work. If you use an IDE, you can ask the IDE to generate this automatically. And actually, when you start working on RxJava, one of the great advantages of doing this is that you get the exact signature of the function. If you don't do this, usually you have a function and you don't know, okay, I have a flat map or filter, what am I supposed to write? If you have the whole function, that you know that what you're going to do is use a function that takes a string as parameters and that will return an observable of something, because it's a flat map, so it's returning an observable of something. And it's just an observable of string. So here I have a function that takes a string and returns an observable of something. And I'm filtering. Filtering is basically I have a document coming in, because that's what flat map returns. This returns an observable of document, so I have a document coming in. And it will return a Boolean, because it's a filtering function if this is true, blah, blah, blah. So it's actually super easy. Easier to understand what operators do if you use something like this. I personally spent a lot of time using this when I started learning RxJava, and I still do for other operators that I haven't shown you, like zip or combinators. I mean, there's some crazy operators you can have to do some crazy stuff. So you have an observable coming in. There's several things you can do. It's a stream. You can wait until you have the totality of the stream and have a list and return the list. Or you maybe just don't care about all the following elements and you want the first one, which is what the first method is doing. Where does that make sense? Let's say you have a node that falls down. Probably not the best example, but you're in a distributed system. In Couchbase, every active document is on only one node. If that node dies for some reason, then this document is not available anymore, only on the replicate. So you need to ask all the replicates, give me that document. This is exactly what it's doing. It's basically telling from all the replicates, give me one document. But now you don't want to wait until every replicate have answered you. You don't care, you just want one document. That's why you would use something like first. With first, you take the first element of the stream, and that's it. You're done. Instead of doing a query to all the replicates, wait until all the replicate comes in, and then use one. You don't care. In that particular use case, you just want one, and so that's why you use first. So it's a PDF, but usually they do this, and people are tired, and people don't know what to think about. So usually I take a 2-minute break, but I'm late, so I'm not going to do it. And hopefully everybody's fine. I could show you this application. I'm not going to show you this application. I'm going to show you the code of this application. What it does is allow you to upload a file and then do a full text query, because you can also do full text query with Couchbase. We talked about it this morning, or nickel queries, and then play the documents. Basic application. If you're not familiar with the Couchbase architecture, we have one kind of node in a cluster on which you can activate several services. The cluster manager is on every node. We are a masterless database. There's no master or slave or controller node. They're all the same. So they all have a cluster manager. They all have a storage and caching layer, because everything starts in RAM and is eventually persisted. Some of them have replication. Basically, if you store data using the data service, you will also store replicates from other nodes. This is why you have replication. And then there's a query and index service. When you run a nickel query, the query engine will get that nickel query, parse the query, gets a query plan, knows exactly which index to talk to, so then query the index node, and then give you the results. And we have a talk about this at 4 p.m. here. So 3 ways, soon 4, to query stuff. Just basic CRUD key value stuff. View queries, which is an incremental map reduce. You build your own index and you query your index. Or good old nickel request. And then soon full text. Again, it's a PDF, so no animation, but what I was supposed to show you is that if you want to spread up the load, you add 2 empty nodes on the right, and you trigger an operation called a rebalance. And what it's going to do is take the different shards of the document and distribute them evenly across all the nodes. So the moment you had just 3 nodes, all the loads of all the application was just spread on this. And if you have too much application, too much load on your server, on your cluster, what you can do is just add 2 nodes to the cluster. There's no data yet. You just said to Couchbase, here are 2 new nodes, and then just with one REST call, do what is called a rebalance, which is, okay, there's 2, now we went from 3 to 5 nodes. I'm going to redistribute evenly all the active document and all the replicates across every node so that I can spread out the load of my application. Talked about this before. More code, more code, more code. I will just skip to error management, because error management is one of the reasons why you want to do async and composable stuff. I talked about timeout before. It's super easy to define a timeout. Now, writing composable and async stuff allow you to do some funky things with circuit breaker. You might have heard of a project called Hystrix. Hystrix is a Netflix circuit breaker. And what it does is allow you to reroute something, basically. Let's say you have 2 Couchbase clusters in 2 different data centers. There's a cross-data center replication, active-active between the 2 clusters. And then one of the data center, for some reason, burns out. No more data center. That was the active default data center. Now your application is going to have a hard time connecting to that data center because it doesn't exist anymore, which should trigger a circuit breaker. En français, on va dire disjoncteur. And this will just close, circuit breaker closes, and instead of asking to the traditional data center that burned down, it's going to close and then redirect you to the backup data center. So you can react to something very easily using Hystrix and RxJava. Yeah, this is also an animation that doesn't work. Basically, they're all like this, and a flow of water, and everything is very coordinated under stress condition, because you can assimilate this as having too much load on a server. If you have lots of application talking to Couchbase, and there's too much load, Couchbase will start sending errors, like backpressure exception. Backpressure means back off. Too much pressure, too much load. you need to do something about this. The very stupid way of answering to this would be, there's an error, retry, there's an error, retry, and more load on the server, and then the server dies. The idea of getting back a backpressure exception is to define a different way of doing things. If you get a backpressure exception, it means back off. It means, okay, I'm not going to retry now. I might retry in 5 milliseconds. And if it doesn't work after 5 milliseconds, I will wait 10 milliseconds and retry, or 15, and etc., etc. So basically, you can define how to reapply or to spread out the load. So basically, it allows you to write retry, fallback, or failing strategy really easily. And it's great because in a distributed system, things will go wrong. The best data system is distributed system is not the system that will tell you nothing will go wrong, it's fine. Because things will go wrong is the one that will tell you if something goes wrong, we'll recover gracefully and everything is going to be fine. So again, I talked about timeouts. I'm just going to show you one last interesting example. Then we'll go back to I'll go to show you some codes and then some questions. This is a mix of RxJava and Couchbase SDK. Retry when is pure RxJava. An exception occurs, so I can define a retry strategy when an exception occurs. And in the Couchbase SDK, we added a retry builder, which is what you see here. And basically, you define a retry strategy. You build a retry strategy. Each time I receive a backpressure exception or a temporary failure exception, it means something is wrong with the cluster, but I was at this particular moment. It might not be true anymore. So what I'm going to do is retry with a delay. And I'm going to say it's an exponential delay, which means every 5 seconds, or 10, 15, etc., for 100 times, I will retry. So you get an error, it's a backpressure exception, you retry 5 seconds after you get the error. You get the same error again, you wait for 10 seconds. You get the same error again, 15 seconds, etc., until 100 times. Now try to think of this, try to write this without using RxJava, without using this composable way of declaring asynchronous function. Try to think about this the synchronous way, doing thread and just no, don't do it. It sucks. Some code, some hard to see code. Get out. Yeah. So it's not a Ratpack application per se. If you're familiar with Spring, you can actually see that this is a Spring Boot application in which I've enabled Ratpack. So what that means is I basically ditched Spring MVC and that old servlet model, and I am now using Ratpack for all the MVC part. You can see that it is a basic Spring application. I can still use the Spring dependency injection framework stuff. And here you can see a Spring Bean. So I'm injecting in the configuration an action chain, which is basically a chain of handlers, which is the way Ratpack defines business logic based on the URL and also the HTTP verb is either get, a post, puts, deletes, whatever, and the content type. Is the content type required a JSON string, application/JSON, or is it text or whatever? And just with this, you can define some interesting things. So here I'm saying is every URL that starts with start file will be handled by this class called the file handler. I have my file handler coming in. Now, based on some things, I will decide what happens. If it's /file/something, which is the regular expression you see here, if the path is /something, then I'm going to retrieve my binary store service, because remember this application is used to store file and extract metadata and to query stuff. I'm going to get it out of the Ratpack context. I could also have auto-wired this, but I might as well just use Ratpack and not Spring. I'm getting the pass token, which is a digest, and then based on the method of the request, I can decide to do some stuff. If the method is get, then I can execute something, which is basically call the binary store to get the file ID and then render the file, which is what you see here. If you remember, I said that Ratpack was using promises. This returns a promise. Once it's done, it executes everything in the context. Now, this can also be mapped to an RxJava observable, and that's what I'm going to show you after this. So we can decide what to do based on the URL, an HTTP verb. This is bad, don't look at this, because it's not implemented. You can delete. And then if there's not another pass attribute, if it's just /file, then it means two things. Either you're doing a get and you want to get all the objects of my API, of my file API, or you're using a post and you want to create a new resource. If I'm doing a get, that's what you have here. Then I'm going to call my search service. It's a Couchbase service. It's using RxJava. It's returning an observable of stuff. It's returning an observable of map of string and object. A JSON is just a string and object. I'm returning a map because I'm using a Java server-side template rendering, so it's easier to give them a map directly than a JSON string. So I have an observable of map that's going to come up, and because Ratpack is using promises, I need to call RxRatpack.promise, give it the observable, and what it's going to do is transform this as a promise. And the moment you transform this as a promise, it's basically doing the subscribe method, that method that starts subscribing to the observable, starts doing all these things, and once it's done, well, you can do whatever you want it to do, which is here, rendering a template with the map of string as object as arguments. And if it's post, then I'm creating a resource. If I'm creating a resource, there's a good chances that there was a form submitted to that application HTTP form. Because I'm using Ratpack, I can pass the form class directly. It's going to return a promise of a form because it's, again, non-blocking and asynchronous. So basically, nothing happens until you finally subscribe or you call then. And once I have my form, I have my upload file, I can start doing some stuff. Now, last interesting bits I like to show you, because I showed that you can add Ratpack in an existing Spring application, but then all the stuff I've showed you were returning either promise or observable. Now there's some stuff, there are some stuff in your application that won't necessarily return observable, that are not async, non-blocking yet, or there's maybe some stuff that cannot be async even if you want to, and I have an example here. What this does, I upload a file, and because I allow people to do query based on the file, well, you don't query on the binary, you query on the metadata of the file. So you need to extract those metadata at one point. And that's what you can see here. Don't look at the blocking part, just look this. This was my original code, and this is spawning a Unix process. It is totally blocking from the JVM. And once it's done, you get the stuff. Now, remember, we need to use promise or observable, and if you wrap all of this into blocking.get, what it's going to do is wrap all this code into a promise, and then send a promise, and then you can keep on working until you subscribe. So it's a way of making your blocking stuff asynchronous and usable in Ratpack. So there's no excuse to not start using Ratpack now, because you can use existing service and existing code super easily. So just by this, I'm returning a promise. I have no more time. Questions quickly until the next person. I'll be outside as well. I had some slides somewhere. Yes. Probably have some of the stuff. If you want some resources, Eric's marbles give you the marble diagram I'll show you, but they're animated in JavaScript. That's quite nice. Some example of async programming with Couchbase. The Ratpack documentation is great. There's a super cool book called Learning Ratpack, and then there's some videos that you have there. If you want to find us, developer.couchbase.com, blog.couchbase.com. You can come on the forum. You can find me on Twitter. You can find us. Waiting for the photo, and then merci. No question? No question. 2 questions. Ils sont déjà en ligne. Je ne sais pas si on vous enverra un email, donc dans le doute, si vous allez sur GitHub, /moi, probablement le premier repo, ça s'appelle Store Search File Async. Il y a les slides et il y a le code. Vous pouvez tout récupérer d'un coup. C'est là. Je peux zoomer si tu veux. Ici, vous trouverez les slides et le code.
Et il y a un slide qui dit on peut scale up le serveur juste en rajoutant les machines et le scale down, enlever les machines, c'est possible.
Scale up ou scale out? Scale out, c'est ajouter des machines. Scale up, c'est rajouter de la RAM ou du CPU. C'est élastique. Tu peux enlever des machines, ça pose pas de problème. On a des clients qui font ça. Typiquement, les gens qui font de la télé. Le mardi, il y a une émission connue où les gens ils doivent voter pour des trucs. Enfin, je sais pas si c'est le mardi, on s'en fout. Et donc, globalement, les mecs prennent un gros pic de charge le soir de l'émission. Donc, en fait, le mardi matin, ils size comme des ports le cluster. Et le mercredi matin, ils enlèvent des nœuds. Et ça marche. On a plein de gens qui font ça.
Ça laisse tout est faisable. Et puis, il y a un autre point dans le slide. Il y a un truc que tu as compris, c'est le map et le flat map.
Ouais.
Pourquoi on fait le query point flat map mais pas query point map?
Alors, map et flatmap, c'est deux trucs différents. Map, c'est une fonction qui prend un objet, qui renvoie un objet. Flatmap, c'est une fonction qui prend un objet, qui renvoie un observable d'objet, mais qui merge tous les observables à la fin. Donc, en fait, flatmap te permet d'être plus asynchrone, et en gros, le taf que tu fais dans flatmap, c'est foutu dans un autre thread, et c'est mieux. Parce que tu bloques pas ton flux de trucs. Voilà, je laisse la place au prochain, parce qu'on a un schedule quand même. Et moi, je suis dehors. Si vous avez des questions, il n'y a pas de souci. Et je suis là toute la journée et toute la soirée. Donc, n'hésitez pas. Merci.